Imagine for a moment that everything you know, everything you've experienced, every choice you've ever made exists not as a singular thread of reality, but as one strand in an infinite tapestry of existence. Somewhere in another realm of being, another version of you made a different choice this morning. Perhaps they chose not to watch this video. Perhaps they chose an entirely different path in life. This is not science fiction. This is not fantasy. This is the multiverse theory, and it challenges the very foundation of what we understand as reality itself. We stand at a peculiar moment in human history where our most rigorous scientific theories have collided headlong with questions that philosophers have pondered for millennia. What is reality? What is existence? Are we alone in our experience of being, or are we merely one manifestation among countless others? The multiverse doesn't just suggest that there might be other universes out there. It forces us to confront something far more profound and unsettling, that the very notion of out there might be an illusion, that separation itself might be the grandest misconception we've ever held. Consider the nature of infinity. We throw this word around casually, but do we truly grasp its implications? Infinity is not merely a very large number. It is not the furthest distance you can imagine, and then some more. Infinity is a concept that breaks our minds because our minds evolved in a finite world, dealing with finite problems. We count our days, we measure our spaces, we quantify our experiences. Everything in human existence operates within boundaries. Yet here we are, confronted by theories that suggest boundaries themselves might be the illusion, that limitation might be nothing more than a failure of perspective. The multiverse theory emerges from several independent streams of scientific thought, each arriving at similar conclusions through different routes. This convergence is itself philosophically significant. When multiple paths of rigorous inquiry lead to the same destination, we must pause and consider whether we're approaching something fundamental about the nature of reality itself. Quantum mechanics, cosmic inflation, string theory, these aren't fringe speculations. They are our most successful attempts to describe the universe at its most fundamental levels, and they all point, in their own ways, toward multiplicity of existence. Let's begin with quantum mechanics, because it presents us with perhaps the most direct challenge to our intuitive understanding of reality. At the quantum level, particles don't behave like anything we experience in our everyday world. They exist in states of superposition, being in multiple states simultaneously until observed. The classic thought experiment, Schrödinger's cat, illustrates this beautifully and disturbingly. A cat in a box with a quantum mechanism that might or might not kill. It exists in a superposition of alive and dead until we open the box and observe it. Our observation appears to collapse the superposition into one definite state. But here's where it gets philosophically explosive. What if observation doesn't collapse the superposition? What if, instead, the universe itself splits at the moment of observation? In one universe, you observe a dead cat. In another, equally real universe, you observe a living cat. Both outcomes occur. Both are real. Both versions of you continue to exist, each convinced that their observation represents the single, definite outcome. This is the many worlds interpretation of quantum mechanics proposed by Hugh Everett in 1957, and it suggests that every quantum event causes the universe to branch into multiple realities, each representing a different possible outcome. Think about what this means for a moment. Every quantum interaction, and there are countless trillions occurring every instant, spawns new universes. The number of parallel universes isn't just large, it's growing exponentially with every passing moment. Right now, as you process these words, quantum events in your brain are causing the universe to split. There are versions of you who stopped reading here, versions who never started, versions who will think deeply about these ideas for years to come, and versions who will forget them by tomorrow. All of these versions are equally real, all equally convinced they are the real you. This proliferation of realities raises profound questions about identity and continuity. What does it mean to be you if there are infinite versions of you making different choices, having different experiences? Is there a privileged version, a true you, or are all versions equally valid manifestations of your existence? The traditional notion of personal identity assumes continuity. You are the same person you were yesterday because there's an unbroken chain of consciousness and memory connecting your past and present selves. But in a multiverse where you're constantly branching into different versions, what becomes of this continuity? Are you the sum of all your versions? Are you just the version reading these words right now? Or is the very question based on a false premise about the nature of identity? The implications extend far beyond personal identity. They touch on free will, one of philosophy's oldest and most contentious questions. If every possible outcome of every decision you make actually occurs in some universe, in what sense are you making a choice? When you decide to turn left instead of right, a version of you turns right. Both outcomes are realized. Does this mean your choices are meaningless? Or does it mean something more subtle? That choice isn't about selecting one outcome over another, but about which version of yourself you become, which branch of the ever-expanding tree of reality you inhabit. Some find this liberating. If all choices are realized, then there's no such thing as a wrong choice in the absolute sense. Every path is taken somewhere. Others find it deeply disturbing. If all outcomes occur, does anything matter? If there's a universe where you made every possible mistake and another where you made every possible right decision, what's the significance of the choices you make in this universe? This is where we must be careful not to let the vastness of the multiverse diminish the reality of our experience. Yes, other versions exist, but you only experience this version. Your choices shape your experience, your reality, your universe. The existence of other possibilities doesn't negate the importance of the actualities you create through your decisions. Let's shift perspectives and consider cosmic inflation, another route to the multiverse that emerges from cosmology rather than quantum mechanics. The theory of cosmic inflation suggests that in the first fraction of a second after the Big Bang, the universe underwent a period of exponential expansion. This inflation explains several puzzling features of our observable universe, such as its remarkable uniformity on large scales. But the mathematics of inflation theory suggests something extraordinary. Inflation, once started, never entirely stops. While it ended in our observable universe, it continues elsewhere, spawning bubble universes, each with its own Big Bang, its own laws of physics, potentially, its own destiny. These bubble universes exist in a vast inflating space, each one an island of distinct reality in an ever-expanding sea of cosmic inflation. They are causally disconnected from us. No signal, no information, no influence can pass between them. They are, in a very real sense, entirely separate realities. and there's no reason to think there are only a few of them. The mathematics suggests an infinite number of these bubble universes, each one potentially infinite in extent itself. Infinity upon infinity, existence multiplied beyond any human comprehension. What's particularly fascinating from a philosophical standpoint is that these bubble universes might have different physical constants, different fundamental forces, different laws of nature. The strength of gravity, the charge of an electron, the way particles interact, these might vary from universe to universe. In most of these universes, the conditions wouldn't allow for complexity, let alone life. The forces might be too strong, causing matter to collapse immediately into black holes, or too weak, preventing atoms from forming. Stars might not ignite, chemistry might not develop, evolution would never begin. This brings us to one of the most profound philosophical implications of the multiverse. It offers a potential explanation for the fine-tuning of our universe. Scientists have long marveled at how precisely calibrated the fundamental constants of nature are for life to exist. Change any of them by even a small percentage, and the universe becomes inhospitable to life. This fine-tuning has been used as an argument for design, for purpose, for cosmic intention. But the multiverse offers an alternative explanation. If there are infinite universes with varying physical constants, then of course some of them, purely by chance, will have the right conditions for life. And of course we find ourselves in one of those universes we couldn't exist anywhere else. This is the anthropic principle. We observe the universe to be compatible with life, because if it weren't, we wouldn't be here to observe it. But does this explanation really satisfy? It replaces apparent design with vast multiplicity, cosmic intention with statistical inevitability. Some find this deeply unsatisfying. The multiverse seems like an extravagant hypothesis invoking infinite unobservable universes to explain the properties of the one we can see. It feels like explaining a mystery by multiplying mysteries. Others argue that the multiverse is more parsimonious than it appears. If the mathematics of our best theories naturally lead to multiple universes, then accepting the multiverse is actually simpler than trying to artificially restrict reality to just one universe. This touches on a fundamental question in philosophy of science. What makes a theory good? Traditionally, we value simplicity, explanatory power, and testability. The multiverse theory is complex in its implications, but potentially simple in its foundations. It's what the math suggests without adding artificial constraints. It has tremendous explanatory power, potentially accounting for fine-tuning, quantum outcomes, and other puzzles. But testability? That's the challenge. If other universes are causally disconnected from ours, how can we possibly test their existence? How can we distinguish between a universe where other universes exist but can't be observed and a universe where other universes simply don't exist? This is where the multiverse theory pushes against the boundaries of science itself. Science traditionally deals with testable predictions, with observations that can confirm or refute hypotheses. But modern physics has led us to entities and phenomena that may be fundamentally unobservable. Other universes, the interior of black holes, the state of particles before measurement. These challenge our notion of what science can address. Does this mean the multiverse is metaphysics rather than physics? Or does it mean we need to expand our understanding of what constitutes scientific knowledge? Some physicists argue that we can find indirect evidence for the multiverse. If cosmic inflation is correct, it should leave specific signatures in the cosmic microwave background radiation, the afterglow of the Big Bang that fills all space. We've already detected some of these signatures. If we found evidence of collisions between our bubble universe and others during the early inflation period, that would be strong support for the multiverse. The search continues, with increasingly sensitive instruments scanning the sky for these subtle signs. Others propose that we might find inconsistencies in the fine structure constant or other supposed constants of nature across different regions of space, suggesting we're in a much larger multiverse where these constants vary. Still others suggest that quantum experiments might reveal signatures of parallel universes interfering with ours at the quantum level. These are ingenious attempts to make the seemingly untestable testable, to bring the multiverse within the realm of empirical science. But perhaps we're asking the wrong question. Perhaps the question isn't whether we can prove the multiverse exists, but whether we can prove it doesn't. This is a subtle but important shift. Our most successful theories, quantum mechanics, inflation, naturally lead to the multiverse. To avoid multiple universes, we have to add assumptions, impose restrictions, artificially constrain the mathematics. In other words, the single universe might actually be the more complicated hypothesis, requiring explanation for why existence limits itself to just one reality when the mathematics allows for many. This brings us to a deeper philosophical terrain. What is the relationship between mathematics and reality? Why should the universe obey mathematical laws at all? And when our mathematical theories point to entities or phenomena we can't observe, should we believe in them? This is a question that goes back to Plato, who argued that mathematical forms are more real than physical objects, that the world we perceive is merely a shadow of a deeper mathematical reality. Modern physics, with its fundamental reliance on mathematical structures, seems to support a kind of mathematical Platonism. String theory, another path to the multiverse, takes this even further. In string theory, the fundamental constituents of reality aren't particles, but tiny vibrating strings. Different vibration patterns produce different particles. An electron is one vibration pattern, a quark another, and so on. String theory is elegant mathematically and has the potential to unify all forces of nature, including gravity, which has resisted unification with the other forces for decades. But string theory comes with a peculiar feature. It requires extra dimensions beyond the 3 of space and 1 of time that we experience. Depending on the version, it might require 10 or 11 dimensions total. These extra dimensions are thought to be compactified, curled up so small that we can't perceive them, like how a garden hose looks one-dimensional from far away, but reveals a second circular dimension when you get close. The way these extra dimensions are compactified determines the physical laws and constants in the resulting universe. And here's the thing, there are an enormous number of ways to compactify these dimensions. Estimates suggest something like 10 to the 500 different possible configurations, each producing a universe with different physical laws. This vast landscape of possible universes, all equally valid solutions to the string theory equations, constitutes another version of the multiverse, the string theory landscape. If string theory is correct, and if somehow all these possible configurations are realized somewhere in the greater cosmos, then we live in one universe among an incomprehensibly vast number, selected not by design, but by the anthropic requirement that it must be compatible with our existence. The string theory landscape multiplies realities, not through quantum branching or cosmic inflation bubbles, but through the vast space of mathematical possibilities inherent in the theory's structure. What strikes me as profound here is how each route to the multiverse quantum mechanics, inflation, string theory emerges from attempting to solve specific problems in physics, not from any desire to multiply universes. Physicists didn't set out to create multiverse theories. They were trying to understand quantum measurement, explain cosmic uniformity, unify fundamental forces. The multiverse is where these efforts led them. This suggests we might be touching something real, something fundamental about the nature of existence itself. But let's push deeper into the philosophical implications. If the multiverse exists in any of these forms, what happens to the concept of natural law? We typically think of the laws of physics as universal, applying everywhere and everyone. But in a multiverse, especially the string theory landscape or the inflation multiverse, physical laws might be local, specific to particular universes. What we call the laws of physics might be more like local regulations, describing how things work in our cosmic neighborhood, but not necessarily anywhere else. This relativizes physical law in a way that mirrors how our understanding of moral and cultural laws has been relativized. This brings up an interesting parallel. Just as humans have grappled with moral relativism, the idea that moral truths aren't universal but vary by culture, we might now be facing physical relativism, but there's an important difference. Moral relativism has been criticized for seeming to imply that anything goes, that all moral systems are equally valid. Physical relativism doesn't have the same implications because we're not choosing our universe's physical laws. We're discovering them. They are what they are, regardless of what we think about them. But the existence of other universes with different laws does suggest that physical law is contingent rather than necessary, that reality could have been otherwise, that there's nothing inevitable about the specific way our universe operates. This contingency raises the question, why these laws rather than others? If physical laws are contingent, selected from a vast landscape of possibilities, what determines the selection? In the anthropic multiverse interpretation, the selection is observational. We necessarily find ourselves in a universe compatible with our existence. But this doesn't explain why the multiverse has the structure it does, why the landscape of possibilities is what it is. We've shifted the question up one level, but the fundamental mystery remains. Why is there something rather than nothing? And why is the something structured in a way that allows for multiple universes rather than no universes or just one? Some philosophers and physicists have suggested that existence might be mathematically necessary. If mathematical structures have a kind of reality independent of physical instantiation, and if the universe is fundamentally mathematical, then perhaps existence is inevitable. Not existing would be logically incoherent. This is a contemporary version of the ontological argument for God, but applied to the universe itself. Existence exists because non-existence is impossible, because the mathematical structures that define reality are necessary truths. But this raises another question. Which mathematical structures exist? All of them? Max Tegmark has proposed the mathematical universe hypothesis, suggesting that all mathematical structures exist as physical realities, that mathematics and physics are identical, that the universe is literally a mathematical object. In this view, the multiverse doesn't just contain all physically possible universes. It contains all mathematically possible universes. Every consistent mathematical structure is realized as a universe somewhere in the vast space of existence. This is perhaps the most radical form of the multiverse theory, and it pushes us to ask, what does existence even mean in this context? If every mathematical structure exists, then existence becomes almost meaningless as a distinguishing property. Everything that can exist does exist. The question isn't what exists, but what we experience, which slice of infinite existence we inhabit. This shifts the philosophical problem from ontology, the study of what exists, to epistemology, the study of what we can know, and phenomenology, the study of what we experience. The fundamental question becomes not what is real, but what is my relationship to reality. This might seem like sophistry, like we're playing word games with existence. But I think there's something profound here about the nature of reality and consciousness. What we call reality is always reality as experienced. We don't have access to some pure, unmediated reality. Everything we know comes through the filter of our senses, our cognitive architecture, our conceptual frameworks. The world you experience is a construction your brain builds from sensory data, and that construction is highly selective. Your eyes receive electromagnetic radiation in a narrow frequency band. Your ears detect pressure waves in a limited range. Your entire perceptual apparatus evolved not to show you reality as it is, but to show you what you need to survive and reproduce. This evolutionary perspective on perception is important for thinking about the multiverse. If our perceptual and cognitive systems evolved to deal with medium-sized objects moving at medium speeds in our particular environment, why should we expect them to give us reliable intuitions about the fundamental nature of reality? The quantum world seems bizarre and counterintuitive to us, but perhaps the problem isn't with quantum mechanics. Perhaps the problem is with our intuitions, which were never designed to comprehend quantum phenomena. Similarly, the multiverse seems extravagant and unnecessary to our intuitions, but perhaps those intuitions simply aren't reliable guides when it comes to cosmology. This raises a broader question about the limits of human understanding. Are there aspects of reality that are fundamentally beyond our cognitive capacity? Not just things we don't currently understand, but could understand with more time and better tools, but things that are in principle incomprehensible to minds like ours? Some philosophers think consciousness might be such a thing that a complete explanation of how subjective experience arises from physical processes might be beyond human intellectual capacity. The multiverse might be another. We might be like dogs trying to understand calculus, lacking the cognitive architecture to fully grasp certain features of reality. But here's an interesting twist. The fact that we can even formulate the multiverse theory, that we can follow the mathematics and logic that leads to it, suggests we're not entirely out of our depth. We might not be able to intuitively grasp infinity, but we can reason about it formally. We can understand what the theory claims, even if we can't fully visualize or imagine it. This is the power of abstract thought, of mathematics, of formal reasoning. It allows us to extend our understanding beyond what our senses and intuitions can grasp. Let's return to the question of meaning and purpose in a multiverse. This is where many people feel the multiverse is not just scientifically speculative, but existentially threatening. If there are infinite versions of you making every possible choice, if everything that can happen does happen somewhere, doesn't this render your particular life meaningless? Why does it matter what you do if every alternative is realized in some parallel universe? I think this reaction, while understandable, is based on a confusion about what gives life meaning. Meaning isn't derived from cosmic uniqueness. Your life doesn't matter because you're the only version of you. It matters because you experience it, because it's real to you, because the choices you make shape your experience and the experiences of others in your universe. The existence of parallel versions doesn't diminish this reality. When you help someone, you help them in this universe, which is the only universe that matters to them and to you. When you create something beautiful, it's beautiful in this universe, where people can experience it. When you love someone, that love is real and meaningful, regardless of what's happening in parallel universes. In fact, one could argue that the multiverse makes certain kinds of meaning more robust, not less. If your actions and choices are meaningful in one universe, and there are infinite universes where similar actions and choices occur, then meaningfulness is not just a local, contingent feature of one reality, but something multiply instantiated throughout existence. The patterns of meaning you create echo across the multiverse. This is not to say that meaning is somehow adding up across universes. You don't get moral credit in one universe for good actions your parallel selves take in others. Rather, it's to say that meaning, like existence itself, is abundant rather than scarce. There's also something liberating about the multiverse from an existential perspective. The anxiety many people feel about having made the wrong choice, about the road not taken, is somewhat resolved by the recognition that all roads are taken somewhere. This doesn't mean your choices don't matter. They determine which version of reality you inhabit, but it does mean you can release some of the regret and anxiety about alternatives. Every possibility is explored somewhere in the vast space of existence. You don't have to carry the burden of all the lives you didn't live, because in some sense, they're being lived. But this also means you don't get to escape responsibility for your choices by imagining they don't matter because other versions exist. The version of you in this universe is responsible for the actions of this version. You can't console yourself that because you failed in this universe, you succeeded in another. That success belongs to another version. Your version must take responsibility for its own path. This leads to an interesting ethical question. Do we have any obligations to parallel versions of ourselves or to people in parallel universes? The answer, at least within the framework of the many worlds interpretation, seems to be no. These other universes are causally disconnected from ours. You can't help or harm people in parallel universes because you can't interact with them. Your moral circle, your sphere of ethical concern, is limited to the universe you inhabit. This might seem like a relief. You don't have to worry about infinite versions of everyone, but it also means the scope of your ethical impact is limited to one branch of the multiverse tree. However, there's a subtler ethical consideration. When you make a choice that causes the universe to branch, you're in some sense determining what kind of worlds come into existence. When you make a kind choice, you're creating branches where kindness occurred. When you make a cruel choice, you're creating branches where cruelty occurred. You're not just shaping your own experience, you're shaping the very structure of reality, determining what kinds of universes exist. This gives a cosmic weight to even small moral choices. Every action contributes to the texture of existence itself. This might seem melodramatic, but it's a logical implication of taking the many worlds interpretation seriously. If quantum events cause branching and your brain is subject to quantum effects, then your neural processes are constantly causing the universe to split. Your thoughts literally shape reality at the most fundamental level, not in a mystical or supernatural sense, but in a straightforward physical sense, within the framework of many worlds quantum mechanics. Of course, the same is true for everyone else. Everyone is shaping reality through their choices. Everyone is determining which branches of the multiverse tree flourish with meaning and connection and beauty, and which branches wither with cruelty and isolation and destruction. In this view, we're all cosmic artists, painting with the brush of quantum mechanics on the canvas of existence itself. The picture we paint is distributed across infinite branches, but each branch is real, and each contributes to the overall texture of what is. Let's consider another aspect of the multiverse, its implications for probability and prediction. In a normal single-universe framework, probability is straightforward. When we say there's a 50% chance of rain tomorrow, we mean that given our current information, rain and no rain are equally likely outcomes. Only one will actually occur, and probability is a measure of our uncertainty about which one. But in the many worlds interpretation, both outcomes occur in different branches. So what does probability mean? This is a genuine puzzle for many worlds. If both outcomes happen, why does quantum mechanics give them different probabilities? In 50% of branches it rains, in 50% it doesn't. So far, so good. But what about when the probabilities are unequal? Quantum mechanics might say there's a 75% chance of one outcome and 25% of another. If both outcomes occur in some branches, what do these percentages mean? The answer has to do with the measure or weight of different branches. Not all branches are created equal. Branches with higher quantum probability are somehow thicker or carry more measure in the mathematical structure of the wave function. You should expect to find yourself in a branch with higher measure because more of your continuations, more versions of your future self exist in high measure branches than in low measure branches. This is a somewhat subtle concept, and not all physicists are satisfied with how well it's been worked out, but it's the leading approach to making sense of probability in many worlds. This brings up fascinating questions about identity over time in a branching universe. From moment to moment, you're constantly splitting into multiple versions. Which of these versions is the real you? The answer seems to be all of them. Personal identity is not a single thread, but a branching tree. You are not one person persisting through time, but a vast collection of slightly different versions, each experiencing their own branch of reality. The person reading these words right now will, in the next moment, split into countless versions based on quantum events in their brain and environment. All of those versions will have memories of reading these words. All will think of themselves as the same person, and in a sense they're all right. This fragmentation of identity might seem disturbing, but in another sense it's always been true. Even without quantum branching, the you of 10 years ago was quite different from the you of today. Your cells have been replaced, your memories have changed, your personality has evolved. Personal identity over time is always somewhat illusory, always a matter of continuity rather than strict sameness. The multiverse just makes this more explicit and more radical. You are not a single thing, but a process, a pattern that replicates and varies across space and time, and now, potentially, across universes. There's a Buddhist resonance here. Buddhism teaches the doctrine of anatta, or no self, the idea that the self is not a fixed, unchanging essence, but a temporary arrangement of components, constantly in flux. The multiverse, especially in its many worlds form, radicalizes this insight. Not only is the self impermanent and composite, it's also multiple. The boundary between self and not self becomes fuzzy when you consider that there are versions of you experiencing slightly different realities, versions that are continuous with your current self but diverging with every quantum event. Let's shift to another philosophical dimension: the relationship between the multiverse and the concept of possibility. In traditional philosophy, we distinguish between the actual and the possible. The actual is what really exists, what really happened. The possible is what could exist or could have happened, but doesn't or didn't. This distinction seems fundamental to how we think. We make plans based on possibilities. We have regrets about unrealized possibilities. We hope for future possibilities. But the multiverse, especially in the many worlds version, collapses this distinction. What we call possibilities are actually actualities in other branches. The possible and the actual become the same thing. This has profound implications for modal logic, the logic of necessity and possibility. Modal logic traditionally treats possibility as an operator that applies to propositions. It is possible that it will rain tomorrow, means there are some circumstances consistent with current conditions where it rains tomorrow. But if many worlds is correct, then it is possible that it will rain tomorrow, means there exist branches of the universe where it rains tomorrow. Possibility becomes a matter of existing in some branch of the multiverse. Necessity becomes a matter of existing in all branches. The modal becomes the spatial, or at least structural. This might seem like a trivial reformulation, but it has serious implications. For one thing, it makes modal claims empirical rather than a priori. Whether something is possible isn't a matter of pure logic or conceptual analysis. It's a matter of whether the physics allows it, whether there's a branch where it occurs. This naturalizes modal logic, grounds it in physical reality rather than abstract conceptual space. It also raises questions about impossible worlds. Are there propositions that are impossible even in a multiverse context? Logical contradictions presumably can't be realized in any branch. You can't have a branch where something both is and isn't the case simultaneously in the same respect. But what about metaphysical impossibilities? Can there be a branch where the laws of physics are violated? In the many worlds context, probably not each branch follows from the same underlying quantum mechanics, even if the outcomes differ. But in the inflation, multiverse, or string theory landscape, different bubbles might have radically different physics. What's metaphysically impossible in our bubble might be possible elsewhere. This brings us to the question of the limits of the multiverse. Are all logically consistent universes realized somewhere in the multiverse, or are there additional constraints? This is related to the mathematical universe hypothesis mentioned earlier. If all mathematical structures are realized as universes, then the multiverse includes everything logically possible. But this raises problems. Some mathematical structures are inconsistent or ill-defined. Do they exist? How can something inconsistent exist? Perhaps only consistent, well-defined mathematical structures are realized, but who or what does the selecting? What determines which structures are realized and which aren't? These questions push us toward what philosophers call the problem of the ultimate why. Why is there something rather than nothing? And if the answer is that all possible things exist, why does possibility have the structure it does? Why these possible things and not others? We can keep pushing the question back, but eventually we hit bedrock, a point where no further explanation seems possible. For some, this bedrock is God or some other ultimate intentional agent. For others, it's brute fact reality just is the way it is, and there's no further explanation. For still others, it's mathematical necessity. The structure of logic and mathematics requires existence to have the form it does. The multiverse doesn't solve the ultimate why question, but it does change its shape. Instead of asking why this specific universe exists with these specific properties, we ask why the multiverse exists with the structure it has. In some ways, this is more satisfying. It explains what seemed like arbitrary fine-tuning in terms of a larger necessary structure. In other ways, it just pushes the mystery back one level. Why this multiverse structure rather than some other, or none at all? Perhaps this is where we have to accept that some questions don't have answers, at least not answers we can access with our current conceptual tools. Perhaps the ultimate structure of reality is just a given, something that is the way it is for no deeper reason. Or perhaps there are levels of explanation we haven't yet imagined. Conceptual breakthroughs waiting to be discovered that will make the current mystery seem as quaint as ancient puzzles about the motion of the planets. One of the most intriguing features of the multiverse from my perspective is how it exemplifies the human capacity for abstract thought. We can conceive of entities and structures far beyond anything we can observe or directly experience. We can follow chains of reasoning into domains utterly removed from our everyday life. The multiverse exists, if it exists, in realms we can never visit, yet we can think about it, reason about it, develop theories about its structure. This is a remarkable feature of consciousness, its ability to transcend its own boundaries, to model realities beyond its direct ken. This capacity is what makes us philosophical beings. We're not content with the world as it appears. We ask what lies behind appearances, what principles govern the patterns we observe, what possibilities exist beyond what we experience. The multiverse is perhaps the ultimate expression of this drive to understand reality in its totality, not just the small corner we inhabit. It's an attempt to grasp the structure of existence itself, to see our universe not as the whole of reality, but as one element in a vaster ensemble. But this drive comes with the danger of losing touch with the immediate, the experiential, the lived reality of existence. We can become so caught up in abstract possibilities that we forget the concrete actuality of our own experience. The multiverse might exist, but you only experience this universe. The tree of branching possibilities might be infinite, but you only walk one path through it. There's a balance to be struck between the cosmic perspective, seeing ourselves as part of a vast multiverse, and the human perspective, living our particular lives with engagement and care. This balance is related to what the philosopher Thomas Nagel called the view from nowhere versus the view from somewhere. Science aims for the view from nowhere, an objective understanding of reality, independent of any particular perspective. But we live from somewhere, from a specific viewpoint embedded in space and time and circumstance. The multiverse gives us the ultimate view from nowhere, a God's eye view of all possible universes. But we experience reality from somewhere, from one branch, one bubble, one manifestation of the vast ensemble. Both perspectives are valid, and wisdom involves holding them together. There's also an aesthetic dimension to the multiverse that deserves attention. The idea is beautiful in its own right, beautiful in the way mathematical theorems can be beautiful. There's an elegance to the notion that reality is not arbitrarily limited to one instance, but realizes all possibilities. There's a kind of ontological generosity to the multiverse. Existence doesn't hoard itself, but expends itself lavishly, multiplying realities with abandon. This mirrors certain theological concepts of divine plenitude, the idea that God creates abundantly because it's in the nature of goodness to overflow, to realize all possibilities for being. The mathematician and philosopher Alfred North Whitehead wrote about what he called the creative advance into novelty, the idea that reality is constantly producing new actualities, new configurations of existence. The multiverse takes this to its logical extreme. If many worlds is correct, reality is constantly branching, constantly creating new configurations with every quantum event. Novelty isn't occasional, it's perpetual, infinite, inexhaustible. The universe is not a static structure, but a continuously proliferating tree of possibilities becoming actualities. This dynamic vision of reality contrasts sharply with older views of the universe as fixed and determinate, everything already decided from the beginning. In a sense, the multiverse makes everything both determined and undetermined. It's determined in that all possibilities are realized, nothing is left out, nothing fails to happen somewhere. But it's undetermined from your perspective, because you don't know which branch you'll find yourself in, which version of the possibilities you'll experience. The future is both fixed and open simultaneously, depending on how you look at it. Let's consider how the multiverse relates to the concept of information. Information theory, developed by Claude Shannon in the mid-20th century, has become increasingly central to physics. Some physicists think information might be more fundamental than matter or energy, that the universe at its deepest level is made of information, not stuff. The famous "It from Bit" slogan captures this idea. Physical reality emerges from information. In a multiverse, the information content is staggering. If there are infinite universes, each with different configurations, the total information content is infinite. But here's an interesting twist. From the perspective of the mathematical structure describing the multiverse, the information content might be quite compact. The many worlds wave function, for instance, is a single mathematical object. It contains all the branching universes implicitly in its structure. So in one sense, the information content is minimal. It's just a wave function. But in another sense, the information content is maximal. It's all the detailed configurations of all the branches. This relates to the concept of algorithmic information theory, which measures the information content of something by the length of the shortest program that can generate it. A random string contains maximum information because there's no way to compress it. The shortest program is just the string itself. But a highly structured pattern can be compressed dramatically. The multiverse might be like this. Its explicit information content, all the details of all the universes, is infinite. But its compressed information content, the mathematical structure that generates it, might be quite simple. If this is right, then the multiverse exemplifies a profound principle. Maximum complexity can emerge from minimal structure. infinite diversity from simple rules. This is already familiar from fractals, where endlessly complex patterns emerge from iterating simple mathematical functions. The Mandelbrot set is infinitely intricate, yet its generating rule is a simple equation. The multiverse might be the ultimate fractal, an infinite proliferation of realities emerging from the simple dynamics of quantum mechanics or cosmic inflation. This has interesting implications for the question of cosmic design. Traditional design arguments suggest that the apparent order and complexity of the universe requires a designer. But if complexity can emerge naturally from simple rules, if the multiverse generates infinite diversity from basic principles, then complexity doesn't require intentional design. It's what happens automatically when you let mathematical structures unfold their implications. Order isn't imposed from outside, it emerges from within. But this raises a different question. Why these particular simple rules that generate such rich complexity? Why quantum mechanics with its branching structure, or inflation with its bubble universes rather than some other dynamics that might generate nothing interesting? We're back to the ultimate why question, just framed differently. The multiverse explains complexity, but not the existence of the simple structures that generate it. Some physicists and philosophers have suggested that the laws of physics might be unique. There might be only one mathematically consistent set of fundamental laws, and they happen to be the ones that generate a rich multiverse. This is a modern version of Einstein's question: did God have any choice in creating the universe? If the laws are unique, if they're the only mathematically consistent option, then in a sense God or reality, or however you want to frame it, had no choice. The universe or multiverse had to be this way. But even if this is true, it doesn't eliminate the mystery. Why should mathematical consistency generate physical existence? Why should abstract mathematical structures correspond to concrete realities? This is the ancient problem of the relationship between mathematics and the physical world, and it remains deeply puzzling. The multiverse doesn't resolve it, it amplifies it. If mathematical structures generate not just one physical reality, but infinite realities, the question of why mathematics is physically efficacious becomes even more pressing. Let's turn to the question of consciousness and the multiverse. Does consciousness do anything special in a multiverse framework? In many worlds, the answer seems to be no. Consciousness is just along for the ride, experiencing one branch while other branches proceed without awareness of each other. But some physicists and philosophers have suggested more radical possibilities. What if consciousness plays a role in selecting which branch we experience? What if the act of conscious observation isn't just passively recording one outcome, but actively selecting it from the superposition of possibilities? This ventures into speculative territory, but it's worth exploring. Standard quantum mechanics says observation collapses the wave function, but many worlds says there's no collapse, just branching. Consciousness in many worlds doesn't collapse anything. It just finds itself in one branch rather than another. But perhaps there's more to say. Perhaps the subjective continuity of consciousness, the sense of being a single self persisting through time, requires something beyond the bare physical branching. Perhaps consciousness threads through the multiverse in ways we don't yet understand, selecting or weighting branches in ways not captured by the purely physical wave function. This is highly speculative, and most physicists would be skeptical. But it points to a genuine puzzle. Why do we experience ourselves as being in one definite branch rather than experiencing the superposition itself. Why does consciousness give us a classical, definite experience when the underlying quantum reality is indefinite and multiple? This is related to the measurement problem in quantum mechanics, and the multiverse, despite its elegance, doesn't fully resolve it. We still need to understand why our experience is classical when the quantum world is not. Another consciousness-related question: if there are infinite versions of you in the multiverse, what's the relationship between them? Are they all you, or are they different people who happen to be very similar to you? This is a deep question about the nature of personal identity. One view says that personal identity is based on psychological continuity. You are the same person as someone in the past or future if there's an appropriate causal connection preserving memories, personality, and so on. By this criterion, your parallel universe versions might not be you, because there's no causal connection between your branches after they split. But another view says personal identity is based on similarity. If someone is sufficiently similar to you in their memories, personality, and physical structure, they are you, or at least share your identity in some robust sense. By this criterion, versions of you in very recently split branches are still you. They're virtually identical to you right now. Versions and branches that split long ago are less clearly you. They've diverged too much. This connects to thought experiments about personal identity, like teleportation. If you're disassembled on Earth and reconstructed on Mars from a blueprint, is the Mars person you or just a copy? Most people's intuitions are uncertain. The multiverse raises similar questions, but even more acutely, because the parallel versions aren't reconstructed from a blueprint. They emerge naturally from the branching structure of quantum mechanics. They have just as much claim to being the original as you do. Perhaps the question is malformed. Perhaps personal identity isn't an all-or-nothing matter, but comes in degrees. The version of you 1 microsecond into the future is you to a very high degree, almost complete continuity. The version of you in a branch that split a microsecond ago is also you to a very high degree, virtually identical in all respects. The version of you in a branch that split years ago is you to a lesser degree. Significant divergence has occurred. Personal identity is thus fuzzy and gradual rather than sharp and binary. This has interesting implications for self-interested concern. Should you care about parallel versions of yourself? If they're continuous enough with you to count as you, then yes. But as they diverge, your self-interested concern should diminish. This sounds cold, but it's actually how we already think about our future selves. You care less about your far future self than your near future self, in part because the far future self will be more different from you now. The multiverse just adds another dimension to this caring, not just about your temporal future selves, but also about your parallel contemporaneous selves. Let's consider the multiverse in relation to narrative and meaning. Humans are storytelling creatures. We understand our lives as narratives, with beginnings, middles, and ends, with plot arcs and character development. But the multiverse threatens narrative coherence. If every choice leads to branching, there's no single story of your life, but a vast proliferation of stories, all equally real. The narrative of your life isn't a line, but a tree, constantly forking. How do we make sense of our lives narratively in such a context? One response is to focus on the branch you're experiencing. Yes, there are infinite other branches, but your narrative is the one you're living. The other branches are, from your perspective, might have beens, even though they're actualized elsewhere. Your responsibility is to the narrative you're creating in your branch, to make it meaningful and coherent even though it's one among many. Another response is to see meaning as distributed across branches. What makes your life meaningful isn't just what happens in one branch, but the overall pattern across all branches. This is a more impersonal view. It cares about the totality rather than the particular, but it has a certain appeal. The tapestry of your existence across the multiverse forms a meta-narrative, a higher-order pattern that encompasses all the particular stories. A third response is to reject narrative altogether as an organizing principle. Perhaps the drive to see life as a coherent story is a cognitive bias, a limitation of our evolved psychology. Perhaps reality is messier, more multiple, less narratively structured than we want it to be. The multiverse forces us to confront this messianism, to accept that existence doesn't conform to our narrative expectations. I find myself drawn to a middle position. Narrative remains important at the level of lived experience. You need to make sense of your life as you live it. But the cosmic perspective reveals narrative as local and partial. There are many stories, all real, all unfolding simultaneously. This doesn't make narrative meaningless, it just contextualizes it, shows it as one way of organizing experience among others. The multiverse also raises questions about probability and expectation in a radical way. If all outcomes occur in some branch, then in a sense every possible future is guaranteed. But from your perspective, only one future will be experienced. So how should you think about probability and make decisions? Standard decision theory says you should maximize expected utility, weighting outcomes by their probabilities. But in many worlds, probability has a different meaning. It's about the measure of branches, not about uncertainty over a single outcome. Should you act differently because of this? Probably not in practical terms. You should still act as if you're uncertain about which branch you'll experience, even though all branches occur. This is because you care specifically about the branch you'll experience, not about the abstract fact that all branches exist. Your decisions shape which branches have higher measure, which versions of your future are more likely to be experienced by your continuations. But there's a subtle shift in how we think about risk. In a single universe framework, a decision with a small probability of catastrophe is risky. You might get unlucky and experience the catastrophe. In many worlds, the catastrophe definitely occurs in some branches, but you should still avoid it because you want to minimize the measure of branches where catastrophe occurs, maximize the measure of branches where things go well. You're not gambling on avoiding catastrophe, you're determining what proportion of your future selves experience it. This might seem like a distinction without a difference, but it changes the phenomenology of decision-making. You're not trying to avoid bad outcomes, you're trying to increase the proportion of branches with good outcomes. It's more like sculpting the future than navigating uncertainty. You're shaping the branching structure itself, determining the texture of existence going forward. Let's return to the question of testability and empirical evidence. Can we ever really know if the multiverse exists? The honest answer is, it's difficult, and for some versions of the multiverse, perhaps impossible. The many worlds interpretation of quantum mechanics makes the same predictions for observations as other interpretations, so choosing between them comes down to philosophical criteria like simplicity and coherence rather than empirical test. The inflation multiverse might leave signatures in the cosmic microwave background, but these are subtle and ambiguous. The string theory landscape is even more removed from empirical test. Does this mean the multiverse is unscientific? Not necessarily. Science often deals with entities that can't be directly observed, but are inferred from their effects. Black holes, quarks, the Big Bang. The multiverse might be similar. We can't observe other universes directly, but we might infer their existence from features of our observable universe that are best explained by a multiverse framework. Moreover, the multiverse emerges from our best scientific theories, not as an arbitrary addition, but as a natural consequence of taking those theories seriously. If quantum mechanics and cosmic inflation are correct, and we have overwhelming evidence that they are, then the multiverse might simply be part of the package. Denying it would require adding extra assumptions to artificially prevent the multiverse from emerging from the mathematics. This is similar to the situation with atoms in the 19th century. Some physicists resisted atoms because they couldn't be directly observed, but the evidence from chemistry, thermodynamics, and other fields made atoms increasingly hard to deny. Eventually, techniques were developed that allowed more direct observation, and skepticism evaporated. Perhaps the multiverse will follow a similar trajectory. Currently unobservable, increasingly implied by multiple lines of evidence, eventually confirmed through more sophisticated observations or techniques we haven't yet imagined. Or perhaps not. Perhaps the multiverse will remain forever beyond direct confirmation, and we'll have to decide whether to believe in it based on indirect evidence and philosophical considerations. This would make cosmology more like metaphysics, dealing with questions at the boundary between empirical science and philosophical speculation. Some scientists are uncomfortable with this, preferring to stick with what can be unambiguously tested. Others embrace it, seeing the investigation of fundamental reality as necessarily straddling the boundary between physics and philosophy. I tend toward the latter view. The deepest questions about reality, why there's something rather than nothing, what exists beyond what we can observe, what the ultimate structure of existence is, have always been philosophical as much as scientific. The multiverse brings these questions into conversation with our most advanced physics, but they remain at heart philosophical questions. This doesn't make them less important or less legitimate. If anything, it shows that science and philosophy are continuous, both part of the human project of understanding reality. The multiverse also connects to questions in the philosophy of mathematics that we touched on earlier. Is mathematics discovered or invented? Do mathematical objects exist independently of human minds, or are they mental constructs? These questions become especially pressing in the context of the multiverse. If all mathematical structures exist as physical realities, as the mathematical universe hypothesis suggests, then mathematics is clearly discovered. Mathematicians are exploring a landscape of really existing objects. But if the multiverse has a more limited structure, only realizing certain mathematical patterns, then the question becomes more subtle. There's also the question of which mathematics applies to reality. Not all mathematical systems are consistent with physical reality as we know it. Non-Euclidean geometry, for instance, was developed as a pure mathematical exercise before Einstein realized it describes the structure of space-time. Perhaps there are other mathematical structures waiting to be applied to physics, structures that might help us understand the multiverse better. Or perhaps the multiverse itself will lead us to develop new mathematics, as physical problems often do. The relationship between mathematics and physics is one of the great mysteries. Why is the universe mathematical at all? Why can we describe physical phenomena with equations? Eugene Wigner famously called this the unreasonable effectiveness of mathematics in the natural sciences. Multiverse doesn't solve this mystery, but it might reframe it. If reality is fundamentally mathematical, if the universe is a mathematical structure, then of course mathematics is effective. It's not a tool we apply to nature, but the very fabric of nature itself. But this raises another question. Which came first, the mathematics or the physical instantiation? Does the mathematical structure somehow generate the physical reality? Or is the physical reality primary, and mathematics is just our way of describing it? In the mathematical universe hypothesis, this is a false dichotomy. They're identical, but this identification is itself puzzling. How can something abstract like mathematics be identical to something concrete like physical reality? What does it even mean for a mathematical structure to exist physically? These are deep waters, and I don't pretend to have answers. But they're the kinds of questions the multiverse forces us to confront. It pushes us to the limits of our conceptual frameworks, challenges us to think in new ways about existence, reality, mathematics, consciousness, meaning. This is part of why I find the multiverse so fascinating, not because I'm convinced it's true, but because engaging with it expands our thinking, forces us to question assumptions we didn't even know we were making. Let me address one more aspect before we close: the cultural and psychological impact of the multiverse idea. How does believing in the multiverse, or even seriously entertaining it as a possibility, affect how we live and think? For some people, it's liberating. The idea that every possibility is explored somewhere takes some of the pressure off. You don't have to live all possible lives that are being lived. You just have to live this one with intention and care. For others, it's distressing. If everything happens, does anything matter? If there are infinite versions of you, what's special about this version? I think the healthy response is to hold both perspectives in tension. Yes, this is just one universe among many, one branch among infinite branches. But it's your universe, your branch, the only one you directly experience. The cosmic perspective gives you humility. You're not the center of everything. Your universe isn't all there is. But the personal perspective gives you responsibility. This is your life to live, your choices to make, your reality to shape. Balancing these perspectives is key to living wisely in a potentially infinite multiverse. The multiverse also affects how we think about uniqueness and significance. In a single universe, certain events or entities might be utterly unique, the only time something like that ever happened or existed. But in an infinite multiverse, everything that can happen does happen, infinitely, many times in fact. Does this rob unique events of their significance? I don't think so. Uniqueness was never what made things significant. What makes a moment significant is its quality, its meaning to those who experience it, not its cosmic rarity. A moment of love, a flash of insight, a beautiful sunset. These are significant because of what they are, not because they're unique. In fact, the multiverse might enhance significance in a way. If meaningful moments echo across infinite branches, if love and beauty and understanding are multiply realized throughout the vast space of existence, then these things are not fragile accidents, but robust features of reality. They're not flukes, but patterns that emerge naturally wherever the conditions are right. This gives a certain cosmic validation to what we value. It's not just our parochial preference, but something the multiverse itself generates again and again. As we come toward the end of this exploration, I want to return to where we began, the sheer strangeness of the idea that our universe might be just one among countless others. This idea violates our intuitive sense of reality as singular and definite. We think of the universe as meaning everything that exists. To be told there might be multiple universes, multiple everythings, is almost incoherent from this perspective. It's like being told there are multiple totalities, which seems like a contradiction. But perhaps our intuitions about totality and singularity are simply wrong, shaped by our limited experience. Perhaps multiplicity is more fundamental than singularity. Perhaps existence is inherently abundant, not scarce. Perhaps the real question isn't why there are multiple universes, but why we ever thought there would be just one. The multiverse, from this perspective, is the natural state of affairs. Singularity would be the strange special case requiring explanation. This flipping of assumptions is characteristic of scientific revolutions. Before Copernicus, it seemed obvious that Earth was the center of the cosmos. After Copernicus, it seemed obvious that Earth is just one planet among others. Before Darwin, it seemed obvious that species were fixed and separate. After Darwin, it seemed obvious that all life is related through common ancestry. Perhaps we're on the verge of a similar flip regarding the universe. Before the multiverse, it seems obvious that there's just one universe. After the multiverse, it might seem obvious that there are many. Of course, the multiverse might turn out to be wrong. Science is fallible, and even our best theories are provisional. The multiverse might be rejected by future physics, replaced by a different framework that accounts for the same evidence without multiplying realities. Or it might be confirmed, becoming as established as the atomic theory or biological evolution. We don't know yet. We're in the midst of the investigation, not at the end. But regardless of whether the multiverse turns out to be true, engaging with the idea is valuable. It stretches our imagination, challenges our assumptions, forces us to think carefully about deep questions of existence and meaning. It's a powerful example of how science and philosophy can work together to probe the nature of reality. And it reminds us that the universe or multiverse is stranger and more wonderful than our intuitions suggest. We are finite beings contemplating infinity, temporal creatures reasoning about eternity, limited minds grasping at unlimited reality. The fact that we can even formulate the multiverse theory, that we can reason about realms we'll never observe, is itself remarkable. It speaks to something extraordinary about consciousness and rationality, their ability to transcend their own limitations, to reach beyond the immediate and local toward the ultimate and universal. The multiverse is not just a scientific hypothesis. It's a mirror that reflects back to us our own nature as rational beings, capable of asking questions that stretch beyond any possible answer, of pursuing understanding for its own sake, of finding meaning in contemplating the infinite. Whether or not other universes exist, the fact that we can seriously consider their existence, that we can build mathematical theories describing their structure, that we can debate their philosophical implications, this is profound. In the end, the multiverse reminds us that reality is bigger than we are, stranger than we imagine, richer than we can fully grasp. It invites us to humility before the mystery of existence, even as it empowers us to investigate that mystery with the tools of reason and observation. It shows us that the universe we inhabit, whatever its ultimate structure, is worthy of our wonder, our curiosity, our careful attention. And it suggests that the quest to understand reality, this reality, or the multiverse if it exists, is one of the most profound and meaningful ways we can spend our finite time in this corner of infinite existence.